is what is the time period? The time taken to complete one cycle is called as time period. So if you see these waveforms, so if you see this figure, is clear? So if you see, this is the, if you consider this time in seconds, this is 20, 40, 50. Okay. So to complete one cycle, it has taken 50 seconds. So the time period of this becomes 50 seconds. So similarly, if you see here, this is 2 pi. Okay. So to complete one cycle, it is taking 2 pi R2. So the time taken to complete one cycle is known as the time period. Next definition is frequency. So what is frequency? This also all of you know. The number of cycles completed in 1 second is known as the frequency. Okay. So but we already know to complete one cycle, what is the time required? The time period is the time taken to complete one cycle. So one cycle, the time required is 2 seconds. That means 2 seconds corresponds to one cycle. So in 1 second, how many cycles you can complete? 1 by 2 cycles. Okay. So the number of cycles completed in 1 second is 1 by 2. That means frequency is equal to 1 by 2 seconds. I'm sorry, 1 by 2 hertz. Okay. The unit of frequency is hertz. So the next one is angular velocity or angular frequency. So angular velocity or angular frequency. So the above frequency is represented in hertz. This is the frequency in radians per second. Okay. So it is represented with omega. So it is defined as the angle traced out in 1 second. So what is the angle made in 1 second? That is known as the angular velocity or rate of change of angle of a periodic function with respect to time is defined as angular frequency. Okay. So the units are radians per second. Okay. So for the sinusoidal waveform, so we know that one cycle corresponds to 360 degrees or 2 pi radians. Okay. So but one cycle means how much time it takes? 2 seconds. Okay, the time period that is 2 seconds corresponds to 360 degrees or 2 pi radians. Okay, so 2 seconds corresponds to 360 degrees. So what is the angle traced per 1 second? 360 is by 2 or 2 pi by 2. But we already know what is 1 by 2. 1 by 2 is the frequency f. So you can write this as 2 pi f. So angle traced in 1 second, that is the angular velocity. So what is the expression for the angular velocity? Omega is equal to 2 pi f, radians per second. The next definition is peak value or amplitude. So the maximum value attained by an alternating quantity during one cycle is called its peak value. So the maximum value, the maximum magnitude of an alternating quantity during one cycle is called peak value. It is also known as maximum value, amplitude or crest value. Okay. So we will use this amplitude word also. So the next important definition is average value. So what is the average value? The average of all instantaneous values of an alternating quantity over one complete cycle is called average value. Okay. So instantaneous values of an alternating quantity, maybe voltage or current or anything. The average value of all instantaneous values. So this is the expression, the average value of any waveform with a time period tau is given by f average is equal to 1 by tau integral 0 to tau f of t dt. So any function f of t which has a time period tau is the average value of this function is given by f average. It is represented by f average, which is equal to 1 by tau integral 0 to tau f of t dt. So other expression we can use, which is easy to calculate the average value is, so all of you know the integral of a function is nothing but the area under that curve. Okay, so this is the area under the waveform in one cycle by the time taken to complete that one cycle, that is time period. Okay, so you can use either this expression or this expression to calculate the average value. So just now we have seen some of the alternating waveforms which are periodic. Okay, so in some waveforms, the waveform has equal positive and negative parts like sinusoidal, triangle. You have already seen those waveforms. Okay, so if equal positive and negative uh, parts, okay, half cycle. So positive half cycle is similar to negative half cycle. Then the average value over a complete cycle will be 0. Okay, so that's why to compute the average value for those type of waveforms, we will consider only half of the cycle, because for the complete cycle the average value is 0. So that's why we will consider only half of the cycle. That means tau is replaced by tau by 2. So what is the expression? F average is equal to 1 by tau by 2 integral 0 to tau by 2 f of t dt. Okay, so this is the expression to calculate the average value when the waveform has equal positive and negative half cycles. Similarly, in terms of area, it becomes area under f of t in half cycle by the time taken to complete half cycle, that is tau by 2. So simply replace tau with tau by 2 if the waveform consists equal positive and negative halves. Is it clear, ma?
Yes, ma'am.
Okay, so the
Yes,
next
ma'am.
definition is RMS value. So it is also known as the effective value. So RMS value or effective value. So what is this RMS value? It is defined as the square root of means. That means average. Okay, square root of average of squares of instantaneous values. So average value is directly the average of instantaneous values. It is square root of average of squares of instantaneous values. Okay, so this is known as the effective value or RMS value. So the average value of any waveform with time period t is given by, this is the expression. So f RMS is equal to square root of, so this symbol 1 by 2. Okay, represent the square root. So square root of 1 by t integral 0 to t f of t square dt. Okay, so square of average of square root. Okay, so square root of average of squares. So again, if you consider the waveforms which have equal positive and negative half cycles. Okay, so if the positive half cycle is exactly same as the negative half cycle, instead of tau, the time period, we can consider only half of the time period because it is square. Okay, so positive square, negative square, it is same. Okay, so that's why there is no need to consider the second one. We can only replace the tau with tau by 2. Okay, so next two more definitions are there. That is form factor. So what is the form factor? For any waveform, the ratio of RMS value to the average value is known as its form factor. So what is the form factor? Kf is equal to RMS by average. RMS value by average value. So next come to the last definition, that is peak factor. So peak factor is defined as the ratio of peak value. Okay, so maximum value means peak value. So peak value to RMS value. Okay, so what is the peak factor? It is the ratio of peak value to the RMS value. So Kp is equal to peak by RMS value. So these are the definitions. So in the second unit, we will start with non-sinusoidal waveforms. Okay, so non-sinusoidal waveforms means square waveform, triangle waveform, sawtooth waveforms. Okay, so all these waveforms are non-sinusoidal. Okay, so we will consider how to determine the average value and effective value. Okay, so the power, voltage, currents are dependent on these values. So after that, we will go for the sinusoidal waveform. So the sinusoidal waveforms are very important because in AC circuit, we are using AC sources, that is alternating voltage source and alternating current source, which are only sinusoidal. Okay. So after the first part, from next onwards, AC means it is sinusoidal. Okay. So why we are considering sinusoidals for AC circuit? Why not triangular? That we will discuss in next parts of the unit. Okay. So first we will study about non-sinusoidal waveforms. After that we will study about sinusoidal. So after discussing the average value and RMS value of the sinusoidal quantities, then we will go for what is the behavior of these elements. So AC circuit means which is excited by sinusoidal sources, and the elements are all the three passive elements. That is not only the resistors, it consists resistors, inductors and capacitors. So we will see how the resistor, inductor, capacitors behaves for sinusoidal voltage source or current source. Okay. So once we know the behavior of these elements, then we will see the series combination, parallel combination, all this. So when elements are connected in the circuit and we are giving AC supply. So what are the voltages and currents? So we will need to calculate the voltages and currents when AC, it is supplied by AC sources. Okay. So this is about the second unit. So first part is we will consider the non-sinusoidal alternating waveforms. So here just we are finding the average value and RMS value of non-sinusoidal alternating waveforms. So the waveform is given to us. We need to find the average and RMS value. So to find the RMS value and average value, we already know the expressions. Okay. So these are the expressions. So if you see, if you know the expression for f of t, then only you can calculate the average value and RMS value. Okay. So what is the first? Whenever a waveform is given to us, we need to write the expression for that waveform, whether it is f of t or I of t or v of t. We will write the mathematical expression of this waveform. Okay. So next we will apply, we will use those equations to calculate average value and RMS value. Okay. So we will see. So this part we already know. In the first unit we have expressed the waveforms. So we have expressed the waveforms are represented as a mathematical expression. We know how to do that, but once again I will review that. Okay. So different types of lines. So first we need to identify what is the time period of the given waveform. So in that waveform, 1 second, ma, please. Hello.
Yes, ma'am.
Sorry for the interruption. So after identifying the time period, you have to identify what are the different lines in that one cycle. So the lines means they may be horizontal lines, vertical lines, or the lines with some slope. Okay. So there is no expression for the vertical lines. You know that. So only horizontal lines and inclined lines. So what are the different lines we will get? Horizontal line are the lines passing through the origin and the lines which are not passing through the origin. So these are the three types of lines we will get. So first consider the horizontal lines. Okay. So if you see the horizontal lines may be on x-axis, that is on the time axis, or it is above the uh, x-axis or below the x-axis. Okay. So if it is above the horizontal axis or time axis, it is represented by the function is equal to k. Okay, so I of t is equal to k, f of t, or v of t is equal to k. K means this value. Okay, so at which value this line is there, that is known as the that is the value of that function. Okay, so for throughout 0 to infinity or from 0 to 1 hour, which is that time. Okay, so it is only a constant. There is no t expression in the right side. Okay, so k value may be 4, 1, 2, 2 amps, 4 amps like that. So if the horizontal line is on the x-axis, then it is 0. So if it is below x-axis, then it is minus a. Again, a is a constant like 4 or 10 volts or anything. Okay, so I is equal to minus a. So if you see, there is no t expression. That means horizontal line means it is constant. There is no t expression in the. There is no t in the expression. So next, coming to the lines passing through the horizon. So see, this is a line passing through the horizon. So if you see, this slope is negative. Okay, that means as the time increasing, the value of the function is decreasing. That is known as the negative slope. Okay, so what is the expression? Whenever a line is passing through the origin, the expression is equal to y is equal to mx. But here the x-axis is t, so it is mt. Okay, so what is the slope m? So this is the vertical difference and this is the horizontal difference. Okay, so this is k and this is t. Okay, t and k. Okay, so this difference, that is t and this difference is k. So vertical difference by horizontal difference, k by t. So here it is negative slope, so it is minus k by t. So what is the current expression here? Because this is the current waveform, I of t is equal to m t, where m is equal to minus k by t. So similarly, positive slope. Sorry, waveform is missed. One positive waveform is missed. Where it is? It's The network is poor, so whiteboard is not coming. So I'm going to desktop. Okay. So the only thing is positive means this line will be like this mark. Okay. So all of you know the same expression I is equal to mt. So what is the only difference? M is equal to k by t. Okay. So instead of below the horizontal axis, it is above the horizontal line like this. Okay. So now consider the lines which are not passing through the origin. So see this one. So this is a positive slope, as you see, as the time increasing, the value is also increasing. Okay. So this line is not passing through the origin. So here this intersection point is important. Okay. So what is this intersection point? This is the intersection point of the line with the horizontal axis. So here that is the A value. Okay. So in this case, instead of mt, the expression is m into t minus a. Okay. So if it is passing through the origin, the expression is mt. If it is not passing through the origin, then it is m into t minus a. Okay. That means you are shifting this vertical axis to here. In this case, what is it becomes t minus a. The origin is t minus a. That's why it is m into t minus a. So again, what is the slope? Slope is the same. So if you see, these are the two ends of the line. Okay. So what is the vertical difference? So this is the vertical difference and this is the horizontal difference between the two values. Okay. So vertical difference by horizontal difference, k by t. So now the same with negative slope. So if you see, this is a line having some inclination and it is not passing through the origin. So here also, whenever the line is not passing through the origin, we have to identify what is the intersection point. Okay. So it is same. I is equal to m into t minus k. So what is the difference between this one and previous one? M is negative here, whereas in the previous case, the slope is positive. So here again, the m is the vertical difference k by the horizontal difference. The only thing is because it is negative, it is minus k by t. So that is the how to express the this line. So these are the different lines. Just we have to identify whether it is positive slope or negative slope. Okay. So if you see, this is a positive slope because this is the time increasing direction. So as time increasing, the value minus k to it is become 0. That means it is increasing. So it is a positive slope. So it is this vertical difference by horizontal difference k by t. The expression is m into t minus a. So this is a, this intersection. So similarly, the opposite direction. So this one. So here if you see, as t is increasing in this direction, the current value is decreasing from k to 0. So this is a negative slope. So m is equal to minus k by t. So vertical difference by horizontal difference. So this is another kind of line. So here this line is also not passing through the origin. But the problem with this line is, if you see from this figure, we cannot find what is the intersection point here. Okay. So in this case, we need to use the formula y is equal to mx plus c, that is mt plus c, where m is equal to y2 minus y1 by x2 minus x1, that is the slope. Okay. Then how to find the c value? Substitute either x1 y1 or x2 y2 in this expression. Okay. Because we know these values to calculate the c. Okay. So this is positive slope. Again, for the negative slope also same. Okay. So with this, we can start the problems. That is, we will calculate average and effective value or RMS value of the non-sinusoidal waveforms. So any non-sinusoidal waveforms. how to calculate average and effective value. So what are the steps? First, identify the time period. Then identify how many different lines are there in that time period. Then write the mathematical expressions for those lines. And then use the formulas. So what are the two formulas? F average is equal to 1 by t integral 0 to t f of t dt. And what is the expression for RMS value? F RMS is equal to square root of 1 by tau integral 0 to tau f of t whole square dt. Okay, so this is the process. So let's start the first problem. So all of you note down the problem. Compute average and effective values of square waveform shown in figure. Yes, what is the time period of this waveform? Yes, ma, what is the time period?
0.2, ma'am.
Yes, others, only one response.
0.2.
0.2, ma'am.
So 0.1, the answer, one answer I got. So it is not 0.1 because so whenever a positive and negative cycles is there, the time period is the time required to complete one positive and one negative. Okay, so there is no problem with these type of waveforms. If no positive and negative, then it is somewhat difficult. Okay, so as long as the waveform consists positive and negative half cycles, the the time taken to complete one positive and one negative becomes the time period. Okay, so this is the positive part and this is the negative part. So 0.1, 0.2, 0.3, 0.4. So 0.2 is the time period. Okay, so all of you write tau is equal to 0.2 seconds. Then identify how many different lines are there from 0 to 0.2. Yes, how many lines are there? Yes, ma. Yes, horizontal lines, vertical lines, inclined lines. So how many lines are there? No response. Am I audible, ma?
Yes, ma'am.
Then tell me how many lines are there between this 0 to 0.2? We have already represented this part, that is how to write the mathematical expressions in the first unit. So how many horizontal lines are there?
2, ma'am.
So
ma'am.
this is 1 and this is 2. Okay. And then vertical lines, this one. Okay. But we know that there is no expression for the vertical lines. Okay. So we need to consider only horizontal lines and inclined lines. Okay. So that means only two lines, this one and this one. So this is a horizontal line above the x-axis. So horizontal lines means there is no t in the expression. Okay. So where is this horizontal line? This horizontal line is at 10. Therefore, v is equal to v of t is equal to 10. That is the so v of t is equal to 10 during So just see the figure. So from 0 to 0.1, this line is from 0 to 0.1. So when t is between 0 to 0.1, v of t is represented by 10. So why 10? Because it is a constant line, horizontal line at 10. So next, what is the second line? The second line is between 0.1 and 0.2. So that's why the time interval is 0.1 less than t less than 0.2. So during this time, it is represented by this horizontal line. This is below this. And where is this? This is at minus 10. So simply V of t is equal to minus 10. Okay. Horizontal line means you don't get t in the expression. If they are inclined lines, then only you will get 10t, 20t, minus 4t like that. Okay. So this is very important. If you write this correctly, then only you will get correct average values and RMS values. If the expression itself is wrong, then the entire solution is wrong. Okay. So now, is that over, Ma? How to represent this V of t mathematically? So this is the mathematical expression of the given waveform. Okay. So next, what is the expression for the average value? The average value expression is 1 by t integral 0 to t f of t dt, or in terms of area, it is area under f of t in 1 cycle by t. But if you see, to simplify the solution or the average value, the waveform consists equal positive and negative. Okay. So therefore, what is the area? So positive area, negative area, same. So you'll get 0 in the numerator. So f average is 0. So in that case, what we need to do? So we need to consider only half of the time period. Okay, when we have defined the average value and RMS value, I mentioned that. So whenever the waveform consists equal positive and negative half cycles, then we have to replace tau with tau by 2. Okay, so this is the formula we will use. F average is equal to 1 by tau by 2 integral tau by 2 f of t dt. Okay, so if you are weak in integration, you can use this formula, which is very easy. Okay, so if you are confident, just you can replace f of t with the mathematical expression. What is the mathematical expression? So t by 2 means only 0.1. So 0 to 0.1, what is the expression? Integral 10 dt. Okay, so you can solve that way. And the second method is using the areas. So area under f of t in half cycle by tau by 2. So this is the half cycle. So if you see, this is a rectangle. Okay. So what is the area of this rectangle? Yes, please respond. What is the area of rectangle?
0.1.
Yes, a rectangle with sides A and B. What is the area?
A into B, ma'am.
So here, this side is 10 and this side is 0.1. So what is the area?
10 into 0.1.
0.5,
So
ma'am.
just all of you see this. So the area under f of t in half cycle, area under means that line and horizontal line. Okay. So this part, the part represented with red color, that is the required area. Okay. So this side is 10 and this side is 0.1. So what is the area? 10 into 0.1. So here it is 10 into 0.1. Okay. So it is equal to, what is 10 into 0.1? Okay, by tau by 2. So what is tau by 2? Tau by 2 is 0.1. So 0.1, 0.1 get cancelled. So you get 10 volts. Is it clear, Ma?
Yes, ma'am.
Okay. So this average value, we can calculate the average value without knowing the expression. Okay. But if you want to use this formula, then we have to write the expression for f of t. Okay. So next, RMS value. For RMS value, we need to use the expression. So there is no alternate for this. Okay. So RMS value. So what is the formula? FRMS. So there is no wrong if you use tau in place of tau by 2 ma. Okay. But this is simplified version. So FRMS is equal to square root of 1 by tau by 2 integral tau by 2 f of t square dt. Okay. So VRMS, because our function is a voltage function, VRMS is equal to, just replace f with V. So VRMS is the square root of 1 by tau by 2 integral 0 to tau by 2 V of t whole square dt. So then I am taking this square root to this side, so it becomes a square. So VRMS square is equal to, so I am substituting tau is equal to 0.2. Okay, so 1 by 0.2 by 2 integral 0 to 0.2 by 2 dt of square dt. Okay, so but in this time interval 0 to 0.1, so what is V of t during 0 and 0.1? So between 0 and 0.1, what is V of t? It is simply 10. So you can replace V of t with the 10 during this time interval. So that's why I have replaced this V of t with the 10. Okay. So this 1 by 0.2 by 2 is 1 by 0.1, that is equal to 10. So integral 0 to 0.1 V of t I am replacing with the 10. Okay. So 10 square dt. So what is 10 square? 10 square is 100. So you can, this is a constant, so you can take out of the integration. So it becomes 1000. And what is the integral dt? Integral dt is t. Okay, with the limits 0 to 0.1. So all of you see the stepwise derivation or substitution. So if you substitute t, so it is 0.1 minus 0, that means 0.1. So 1000 into 0.1, that is 100. So what is this 100? This is VRMS square. So VRMS is equal to square root of this 100, that is 10 volts. So all of you see this one? Any doubts? So horizontal lines, it is very easy because there is no t. It is a constant, you can take out of the integral. So all of you calculated the average value and RMS value of the square or rectangle waveform. Yes, no response. Are you listening or not?
Listening, ma'am.
Then please respond, ma. Is it clear how to calculate the average value and RMS value?
Yes, ma'am.
So you already calculated the average values and RMS values in your mathematics. Okay. So what is the difference? There, instead of waveform, directly mathematical expression is given to you. But here, the waveform is given to us. From the waveform, we will write the expression for that function, and then we will use these formulas to calculate average and RMS value. Okay. So if the first problem is clear,
Yes, ma'am.
Ma'am.
Yes, ma'am.
okay, so in next class we will solve more number of problems. Okay, that is triangle, sawtooth waveform, trapezoidal. So many non-sinusoidal waveforms are there. So we will calculate the average and RMS values of those waveforms. Okay, so if you have any doubts in this class, you can stay and ask me. Otherwise,